we are going into lesson 7-4 today. I will kind of give you a little bit of a heads up that, so I am opting not to do a quiz in this chapter, okay? Which means next thing will be is the chapter 7 test. Now, chapter 7 test, depending on what happens between now and then, it's tentatively, I'm thinking next Friday, okay? Obviously, that could change one way or another depending on the situation. But tentatively, I'm looking at next Friday for that. So just kind of a heads up there. We have 7-4, 7-5, and 7-6 to get through this week. So, and maybe a little into next week. Today, we are continuing in our logarithm world. We are talking about properties of logs. So, if you would please start looking at those properties of logs that are at the top of your paper. I'll just kind of run through them and then we'll get to our examples. We have something called the product property. Product means what? Multiplication, yes. So obviously this involves multiplication. Our product property says if you have a log where the insides are being multiplied, then it can be rewritten as two logs that are split up and added. Or you can think of it the other way. Two logs being added can be rewritten as one log where the insides are multiplied. Now, keeping in mind, this of course means that both logs involved have the same base. It doesn't work if you have two different bases. So, for example, log base 6 of 8x. What do you know about 8x? That is 8 times x. So that could be written as log base 6 of 8 plus log base 6 of x. So that's the product property. The quotient property, same idea, but using division. If you have a log and the insides are being divided, that could be rewritten as two logs with subtraction. Or two logs being subtracted can be rewritten as one log where the insides are divided. For example, log base 2 of 8 over 3, log base 2 of 8, minus log base 2 of 3. We have a power property. A power property, of course, refers to the power. And the idea here is if you have an exponent on your log, that exponent can be moved out front, like here, to be the coefficient. So if it's log base b of m to the n, we have the option to move that n out front and make it n times log base b of m. For example, right here, log base 2 of x squared can be rewritten by moving that power of 2 out front to become 2 times log base 2 of x. And then our final property we're going to work with today is the identity property. Log base b of b equals 1. What do you notice there? The b's are the same, yes? If we have log base b and the inside is b, that's the identity property. That value is equal to 1. As long as the numbers in the b places match. So, for example, log base 2 of 2 is going to equal 1. I could say log base 5 of 5. And you know it's still going to equal 1. Now, the twist on this is if you have something such as log base 2 of 8. What do we know about 8? Okay. According to our new paper, 8 is 2 to the third. And so if 8 is 2 to the third, and we rewrite that, log base 2 of 2 to the third, well, because those two match, this is just going to equal the power of 3. So kind of like if we backtrack to this one, log base 2 of 2, what's the invisible power there? That invisible power is 1, and that's what my log equals. This one, log base 2 of 2 to the third, it equals a 3. Okay, and that can be done with any power. So those are the different properties we're going to use. We're going to use them forwards and backwards, so we're going to be using them in multiple different directions. My first examples to get us started today are all about simplifying logs. So taking multiple logs and putting them together as one log, as simplified as possible. So when they're asking you to simplify, write what is each expression written as a single log, use your properties to push them together. So as we look at example A, log base 4 of 32 minus log base 4 of 2. Any thoughts? I heard it. Quotient property? Because I see subtraction, right? Subtraction can be rewritten as one log where the insides are being divided. So I'm going to rewrite this as log base 4 of 32 divided by 2. That's all according to my quotient property. Are we okay with that step I just took there? Now, am I done? No, you want to keep going for as long as you can. Now, the obvious part here. Yeah. What is 32 divided by 2?
16 over 1, which is 16.
Okay, so I can rewrite this as log base 4 of 16. Are we okay with that? I saw division, so I did it. Any other thoughts on this problem?
Yes.
What? I don't want to do left, right, middle, because I do want to express it as a single log here.
Okay. Good guess.
And I don't know what you're doing might work out to be the same, but not. It is going to work out to be the same actually, but I want to use our properties. What do you guys know about 16?
It's pretty short. It's perfect square.
16 is perfect square. It's 4 squared.
Yeah.
Okay. Now, technically, 16 is also 2 to the 4th. But which one's better in this situation? Because this is already log base 4, let's rewrite 16 as 4 squared. Meaning, I can rewrite it as log base 4 of 4 squared. What does this simplify to be then? 2. Because of our identity property here, when your base and the inside base match, it's equal to whatever the exponent is. So my 4's match, and so it's equal to
2.
2.
I get it now.
Okay.
You don't put log?
Nope. At this point, because it simplifies to 2, you don't need to write the word log.
Okay.
Now, Jonathan, you mentioned doing a left, right, middle, and you still got 2, didn't you? Yeah. So the idea here is I'm trying to get us more to think in terms of properties. But it just goes to show it ties right back to what we've been doing. Okay, left, right, middle will still get you there in this situation because it was numbers and it did simplify farther. So, okay, questions on this one? Okay, let's try B. 6 log base 2 of x plus 5 log base 2 of y. Thoughts on where to begin? Okay, yeah. The one thing I'm going to say, I heard product out there from some of you. Hold that thought. I can't use product yet. And why can't I use product yet? Because I have coefficients. I have numbers in front of my logs. Yeah, so I can't use product yet, but how can I move that 6 and that 5? I can move that 6 and 5 by using my power property.
Yeah.
So power property says this 6 can move and become the power on the x. The 5 can move and become the power on the y. So if I use my power property here, log base 2 of x to the 6th plus log base 2 of y to the 5th. So before you go for product or quotient, make sure any numbers that are out front are moved up into the powers. So log of x to the 6th plus log of y to the 5th. Now what do I want to do? Now I can do the product. If two logs are added, it can be rewritten as one log where the insides are multiplied.
Now, does it matter if it's a plus or minus?
Yes. This is a plus, so it's multiplying. Now, right now I have log base 2 of x to the 6th, y to the 5th written. However, I'm not crazy about this form this is written in because what are the insides of the log? What does the log go with? Are x and y in the log, or is it just x? And so, always good here is to put parentheses. When you have more than one item that is part of the inside of the log, always good to put parentheses there. Because that just indicates that yes, x and y are both within my log. Anything else?
That's all we can do, isn't it?
Yeah. Because they're x and y, I can't really go any further. If there were numbers, things might still be able to happen. But they're x and the y, I'm pretty much done right there. So, what? I think they would. My guess is they might automatically put them in there for you, but I don't remember how Math Excel does it. Although the more I think about it, you might have to put your own parentheses in. So, yeah, I'm not remembering off the top of my head, but be where they might require parentheses. I'll put it that way, okay? We're ready for C? Okay, let's try C. Log base 4 of 5x plus log base 4 of 3x. Thoughts on what I'm going to write down here?
Yeah, it's a plus, it's multiplication. So you want to do log small 4. And
then as he said, because it's a plus, when we rewrite as one log, we are going to do multiplication. So I'm fine with, let's write it as, what are the pieces we're multiplying? 5x times 3x. And I'm fine with that as a start. Does that mean I'm necessarily fine with this as final answer? Depends on the situation. I would prefer in this case you go one more step. In that, what is 5x times 3x? 15x squared. So I can rewrite this as log base 4 of 15x squared. We've got that x in there again. So not really a whole lot I can do with it since I have that x in there again. One comment I want to make. Could I bring that 2 out front if I wanted to?
No.
Why not?
Because it's in parentheses.
Okay.
I guess, I don't know.
I agree I cannot bring that 2 out front. I want a little more explanation there. I mean, he says because it's in parentheses. Is this 2 on everything there?
no, it's only on that X.
It's only on the x. If we were going to use our power property, that 2 would have to be on everything that's part of the log. So it'd have to be on the 15 as well, which it's
When you say
not.
on the outside, like on the right side of the closest.
Yeah, well, like if the 2 was out here and it was on the whole 15x,
Yeah.
then I could use my power property to write the 2 out front if I needed to.
When you said outside, I was thinking like before the log. That's what you
Okay, So that one, there's a variable in it. We're kind of done there. There's only so far you can go when you have variables in there. Okay, you ready for D? 2 log base 4 of 6 minus log base 4 of 9. So we have a starting step. Power property. I can't put two logs together as long as there's a number out front of either of them. So this 2 that's out front of my first log needs to move to the power. So 2 log base 4 of 6 can be rewritten as log base 4 of, what if I say 6 squared? And it's still minus log base 4 of 9. Where are you going next?
That's where it's set.
Okay, what is 6 squared?
36.
So log base 4 of 36 minus log base 4 of 9. Okay. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So log base 4 of 36 divided by 9. 36 divided by 9 is 4. Log base 4 of 4.
1.
And according to our identity property,
This is
remember up here, log base 2 of 2 is equal to 1. Log base 4 of 4 is equal to 1. Anytime those numbers match, it's a plain old 1. Okay, you getting the idea there? Okay, we just spent that time working on taking multiple logs and putting them together as single logs. Guess what?
single logs and
We're gonna
double
do the
logs.
We gotta do the opposite. We gotta take one log and break it out into multiple logs. Or, as what they say here, write it in expanded form. So our first example, log of 4x over y. And we're going to expand this as much as we can. What do you see to start with? Okay. What I would like to think is fairly obvious to everybody is I see a fraction bar, right? Our fraction bar represents division. And so this is our quotient problem. So I can take log of 4x over y and split it into 2 logs. Log of 4x, what's my sign here? Minus log of y. Any other thoughts on this problem? Okay. We do not have a base written, which means we could write in base 10 if we wanted to. Do we have to? No. There's another something we can do here. You guys already split up the obvious division. What else is there? What do you see, Megan? Because 4 and x are what? If it says 4x, what's that mean? 4 times x, right? So even though your brains are just wanting to say, oh, 4x. But 4x is 4 times x. And if the inside is multiplication, that can be rewritten as 2 logs being added. So we're going to take log of 4 times x and rewrite it as log of 4 plus log of x, and then still minus log of y. You have to watch out for this. They don't want you to just do one basic step and stop. They want you to break it up as much as you possibly can. Now, at this point, I have 2 different answers boxed on my notes. I do have this answer as a possible answer. However, there's also another little something that we could possibly do. And I'll be honest, in this situation, I don't know. I don't have a gut feeling as to which is better necessarily. My hint is think about the number 4. Yeah, is 4 on this lovely paper that you have out and you're using as your guide? Yeah, we know 4 as being 2 squared, which means I could take log of 4 and rewrite it as log of 2 squared. Now, if it's log of 2 squared, what's one final thing I can do to log of 2 squared? Yeah. I could take this power of 2 and move it out front. If I take that power of 2 and move out front, this is 2 log of 2. I still have plus log x minus log y. It's all about expanding as much as you can, okay? So that 1 log 4 versus 2 log 2, I honestly cannot say which math Excel is going to want, or they may not give you that scenario. But to me, it's still a good scenario to address. So, questions there? Okay, now, you will notice I kind of went over under B a little bit, didn't I? And so if I'm already over under B, then that's going to push B into C, so on and so forth. So I am going to do all 5 examples, but what I'm going to do to kind of be able to fit these all in, and you can do this how you want, but I'm going to take my example B, I'm going to put it down here below. Adjust your paper however you want. This is just my way of compensating for the fact that I'm going to run out of room. I don't have room to put all 5 of these across the way I do it. So log base 9 of x to the 4th over 729. Do you see the obvious? Maybe I shouldn't use the word obvious, but I think it's kind of obvious. What do you see? Fraction bar. Fraction bar indicates division, which means division inside a log can be rewritten as 2 logs being subtracted. So I can start off writing log base 9 of x to the 4th minus log base 9 of 729. I would like to think everyone can get to that point. Next thoughts. Move the 4 over. Power property says I have that power of 4. I can take that power of 4 and move it out front. So that is 4 log base 9 of x. Anything else?
9 works out to 3 squared. Right?
What did you say?
9 is 3 squared.
9 is 3 squared, but it's not the base I want to try and break up. It's the big number. It's a 729.
Yeah. To the third power.
This is why you have this paper. Do I expect you to know a whole lot about 729? No, I'm not expecting you to know much about 729. However, I have eyes, and I can read, and I see a 729 on this paper. 729 is 9 to the third. Might that be helpful? Let's rewrite it and see what we see. Minus log base 9 of 9 to the third. Was that important that we did that? Yeah, because it's log base 9 of 9 to some power, because those 9s match, this just cancels out to be a 3. So I now have 4 log base 9 of x minus 3. So it's important that you have that paper. We all still have our papers.
Yeah.
Did everyone get one, I guess, to begin with? Let me start with that. Everyone's got one? Had one? By all means, they're over there. You can always grab another one, or I can hand you another one if it has gone MIA already. Okay. Are you seeing what to look for here to break these up? Ready to try C then? Let's try C. Log base 3 of 250 over 37. I hate to use the word obvious, I really do, but is it not obvious? I feel like obvious is a good word here. What do you see? Fraction, right? Fraction says I'm going to rewrite this as 2 logs being subtracted. This is my quotient property. So log base 3 of 250 minus log base 3 of 37. You'll notice I'm writing C back up right underneath C. And then when I get to D, I'll put it down below again. Again, somehow figure out a way so you can get these all on your paper. Okay, any thoughts? Okay. So if we address the 37, what do you know about the number 37? It's prime, yes, meaning the only way you can get 37 is 1 times 37. So am I going to find 37 having any powers? No. So that 37 part is definitely done. 250. This is the more debatable one. Did you find 250 on your paper? Okay, so 250 we haven't found on the paper. And so it's kind of questionable which way we go with this, but I'm gonna push you guys a little bit. 250 is not on this paper, I agree. But there are numbers that go into 250 on this paper. So let's try and find a number that goes into 250, which means it is a factor of 250 that I can use. So what goes into 250? What was it? Okay. 125 goes into 250, yes?
Yeah.
Technically 25 also does, but the bigger the better. So 125 times 2 is 250, yes? Okay, let's work with this. I'm going to rewrite. This is log base 3, and 250 I'm going to write as 2 times 125. I'll pick up the log 37 at the end. Now, I just wrote that as multiplication. What do you know about multiplication? It can be rewritten as 2 logs being added. So I can write this as log base 3 of 2 plus log base 3 of 125. What did we decide about 125? 5 to the third? That's according to my paper, right? So that is log base 3 of 5 to the third. What about this 2 here? Log base 3 of 2. 2 is just a 2. That's another prime number. What is the one last thing I can do with log base 3 of 5 to the third? Use our power property and move that 3 out front, which means that becomes 3 log base 3 of 5. Out front, what piece did we have? Log base 3 of 2 plus the 3 log base 3 of 5. And you didn't forget about already, did you? What else was part of this problem? Minus log base 3 of 37. That is your expanded form. And you'll notice if you look at the insides of the logs, the 2, the 5, and the 37. We got it down to all prime numbers is what happened here. Okay? Now, that's a big one. Okay? I'm looking more like the basics, the others that, those are the ones you should definitely be feeling confident with. This one, this was a push. Okay? I'm not expecting that you would have necessarily gotten that on your own at this point. But I'm hoping you could follow the pieces at least. Does D look a little bit better then? Okay, let's try D. We still have time, so. My D is going to drop down here to this bottom level, just because of spacing for me. Okay, log base 3 of 9x to the 5th. What do you see? There's got to be one thing that we can see at this point. Now, granted, this one's different than the last 3, but still, I'd like to think we can see it. Huh? What about the 5? What if I say not yet to pulling the 5 out front? Now, why am I saying not yet to pulling the 5 out front? Does that 5 go on everything that's in there? Technically, that 5 only goes with the X. So I'm going to say not yet. Hold that thought. We will do that step, but I don't want to do it now because it wouldn't be correct right now. What do you see? Okay. Okay, so the first thing that needs to happen, Can you guys see that 9x to the 5th is multiplication? It's 9 times x to the 5th. And so your insides being multiplied are going to split into 2 logs being added. What base was this? 3. So log base 3 of 9 plus log base 3 of x to the 5th.
That's as far as I know. My channel, and then 3 to the third. I don't know. That's what I did. Just ended up right.
Okay. Okay, so there's multiple things happening here, right? So we took the multiplication, we split it into 2 logs. Log base 3 of x to the 5th, what can happen now? Now I'm ready to talk about Megan's, let's bring the 5 out front. Because it's just the x to the 5th on that piece, you can take that 5 out front, yes? And so this part is 5 log base 3 of x. What about that first one? What about log base 3 of 9? Can I do anything with it?
Oh, I was like 3 and 3
Okay. 9.
Yeah, that's
I would say 9's on your paper, but please tell me you know this one. I mean, I would like to think you don't need the paper for this one, but you never know. What is 9?
3 squared.
3 squared, yes. Is there advantage to writing it as 3 squared? Yeah. So if I rewrite this as log base 3 of 3 squared. What do you know about log base 3 of 3 squared? Okay, so for two totally different things, they're both going to get me to the same thing at the same point. One of them said bring the 2 out front. I don't even know which one it was at this point. Okay, so we can take the 2 out front, yes? So that becomes 2 times log base 3 of 3. But what do we know about log base 3 of 3? Our identity property says log base 3 of 3 is 1 times the 2 that got moved out front, and 2 times 1 is 2. Or what's the shortcut on this? Log base 3 of 3 to the second, if these 3's match, what is this log equal to? The power of 2. So you could just go straight there and say this is 2 plus 5 log base 3 of x. Can I add 2 and 5?
Can you? I don't know. You said that I don't think you can. I don't know.
I don't know.
The 5 is log attached to it, though, doesn't it?
Okay, so the 5 is attached to the log. So can I add the 2 and 5? No, because the 2 does not have an equivalent log attached to it. So yes, we're boxing it, we're done. We will start off with E tomorrow. So your job while I'm getting attendance tomorrow will be to work on part E and see how you can do.